In this video, we'll be going over some differentiation applications AP calculus question. The derivative of function a is given by a prime of t equals 2 plus 9e to the 0.4 times sine of t, and a of 1.2 equals 7.5. If the linear approximation to a of t at t equals 1.2 is used to estimate a of t, at what value of t does the linear approximation estimate that a of t equals 15? So we're going to be solving this question in the form of y minus y1 equals m times x minus x1. The derivative is going to be our slope, which is also m. A of 1.2 is going to be y1. T is going to be x1, right? Because that's what we plugged in to get y1. And a of t is equal to y. Remember that t is basically our x in this y minus y1 equals m times x minus x1 equation. So let's plug in everything that we know. Y is 15. y1 is 7.5. M is our derivative, so 2 plus 9e 0.4 sine of 1.2 times t minus 1.2. So you can plug all of this into a calculator and figure out what t is. 15 minus 7.5 is going to be 7.5 equals, this is going to be equal to 15.066 34985 t minus 1.2. Now we're going to distribute. So 7.5 equals 15.066 34985 t minus 18.0796 1982. Now the reason why I'm keeping all these decimals is because we should only round at the end, not near the beginning. So I'm going to add 18.07961982 on both sides. So that equals 25.5796192 is equal to 15.066 34985 t. We're going to isolate t by dividing by 15.066 34985, and you're going to get t equals negative 1.698 if you round it up. And remember, in AP Calculus, we round to 3 places. So that's how you do this question. A particle starts at time t equals 0 and moves along the x-axis so that its position at any time t is greater than 0 is represented by the equation x of t equals t to the 4th minus 3t cubed plus 3t squared minus 1t, where t is in seconds and x of t is in meters. Find the value of t when the particle is moving and the acceleration is 0. So we need to find what acceleration is and set that equal to 0. The first derivative of the position is going to be the velocity. So that's 4t cubed minus 9t squared plus 6t minus 1. The second derivative of position is going to be acceleration. So we have 12t squared minus 18t plus 6. We can factor out 6 and get equals 2t squared minus 3t plus 1. Now we factor it. So we have 2t here, t here. So what two factors multiply to get us 1 and add to get us -3? I'm thinking 2t minus 1 times t minus 1. We can double check this. 2t minus 1, t minus 1, 2t squared minus t minus 2t and 1. So we get 2t squared minus 3t plus 1. And that matches with this one. So we're good. Now let's set these two values equal to 0. 2t minus 1 equals 0. T minus 1 equals 0. Add 1 on both sides. T equals 1. Add 1 to both sides. 2t equals 1. Divide by 2. T equals 1/2. Now these two values are when the acceleration is equal to 0. However, this is when the particle is moving. This is a really important part here, because that means a velocity does not equal to 0. So let's plug it into our velocity equation and see what t value matches both of those requirements. A cube of sides of length s inches has volume v of s equals s cubed cubic inches. The volume is increasing at a constant rate of 40 cubic inches per minute. At the instant when s equals 2, what is the rate of change s in inches per minute with respect to time? So we know that v of s equals s cubed. Let's find the derivative. It would be dv over dt is equal to 3s squared times ds over dt. And this is what we're trying to find. It is the rate of change of s. We know that dv over dt, which is the change in volume, is going to be 40 cubic inches per minute. So you write 40 is equal to 3. We know that s equals 2, so 2 squared times ds over dt. 40 equals 3 times 4 ds over dt. 40 is equal to 12 ds over dt. So ds over dt is going to be 40 divided by 12, which is going to be 10 over 3 inches per minute. And that is your answer. If c and d are positive constants, then evaluate the limit as x approaches infinity of ln of cx squared plus 6 divided by ln of dx plus 8. Remember, when you find the derivative of ln of x, it's going to be 1 over x. So we have 1 over cx squared plus 6 multiplied by the derivative of this. So it's going to be 2cx. This is because of the chain rule. You're going to divide this all by 1 over dx plus 8 multiplied by d, again due to the chain rule, 2cx over cx squared plus 6 divided by d over dx plus 8. We're going to be doing keep change flip. We're going to keep this 2cx over cx squared plus 6. And we're going to flip this, so multiply by dx plus 8 divided by d. So that's going to equal 2c dx squared plus 16cx divided by c dx squared plus 6d. Do L'Hopital's rule. And we have 4c dx plus 16c divided by 2c dx. L'Hopital's rule again, 4cd over 2cd, which gets us 2 as the answer. Let x and y be functions of time that are related by the equation 2x squared plus 3y squared minus 4xy equals 36. At time t equals 1, the value of x is 2. The value of y is negative 2, and the value of dy over dt is 4. Find the value at dx over dt at time t equals 1. First thing we're going to do is find the derivative of this. So we get 4x dx over dt plus 6y dy over dt. We have this negative 4xy. Let's treat negative 4x as one term and y as the other. So it would be the derivative of negative 4x, which is just negative 4 dx over dt multiplied by y plus negative 4x times dy over dt. And the derivative of a constant, in our case 36, will just be 0. So let's plug in what we know. We know x is 2, so plug in 2 dx over dt plus 6, y is negative 2, dy over dt is 4, minus 4 dx over dt times y, which is negative 2. Negative 4 times 2 times 4 equals 0. So 8 dx over dt minus 48 plus, right, because we have two negatives here, 8 dx over dt minus 32 equals 0. Combine like terms and move them to the right. You get 16 dx over dt equals 80. Divide by 16, dx over dt equals 5. So our velocity equation was just the derivative of the position. So 4t cubed minus 9t squared plus 6t minus 1. Or plug it in, t equals 1/2 and t equals 1. So x prime of 1/2 is just 4 times 1/2 cubed minus 9 times 1/2 squared plus 6 times 1/2 minus 1. So we can plug that into our calculator. And we get that it's not equal to 0. So this is good. This t value is good because it fulfills both requirements. Now let's plug in 1. 4 times 1 cubed minus 9 times 1 cubed plus 6 times 1 minus 1. So that's 4 minus 9 plus 6 minus 1. And we get x prime of 1 equals to 0. That means that the particle didn't move. So we cannot include that t value in our solution. So the answer would be t equals 1/2, fulfilling both of those requirements of moving and the acceleration equaling to 0. So we can cross out t equals 1. F of x and h of x are twice differentiable functions. The function h of x satisfies h of x equals x squared minus 9 divided by 1 minus f of x cubed, for x does not equal 3. Using L'Hopital's rule, we can determine that the limit as x approaches 3 of h of x equals 1. Use this information to find f of 3 and f prime of 3. So remember, when we're using L'Hopital's rule, the guideline is it needs to be 0 over 0. So we're going to set this equal to 0. 1 minus f of x cubed equals 0, minus 1 on both sides. Negative f of x cubed equals negative 1, divided by negative 1. F of x cubed equals 1. The cube root of that, and you get f of x equals 1, which means f of 3 is also equal to 1, because any x value you plug in will equal 1. Now we're going to find the derivative of this. 2x over negative 3 f of x squared times f prime of x equals 2 times 3, negative 3 times 1 squared times f prime of x equals 6 over negative 3 times f prime of x. 6 over negative 3 f prime of x equals 1. We're going to multiply 6 on both sides. And we get negative 3 times f prime of x equals 6. Divided by negative 3, f prime of 3 equals negative 2. Please subscribe. Hit the notification bell so you never miss a video. Like, comment, and share this video. Follow us on Instagram, Facebook, Twitter, and TikTok at High School Math Analyzers. Thanks for watching. We hope this video was helpful to you, and we'll see you in the next one. Been stabbed in the back bed, I show you what